Hi. So we're discussing a sequence. Now, in general, we write a sequence using an, just an equals something. That will give you the formula for the nth term, and then you can use that to find any term of the sequence. Sometimes it's written inside second braces. Okay, that's also another way. So these are just the terminologies. Okay, an, bn, cn. It doesn't have to be an. Okay, this type of notations are used. So for example, let me give you examples now. If I say, here is a sequence. Okay, that's my sequence. And I ask you, let's say, can you give me the first 4 terms of this sequence? Okay, so I want you to start writing the terms. Can you do that? How will you do that? So usually, like I said, n starts from 1, unless we mention it otherwise. If it starts at a different value, we'll probably write it down from here to here. But otherwise, starts at 1, goes up to infinity, okay? So what am I going to do to find the first term? I'm going to plug in n equals 1. So plug in n equals 1, what do you get? -1 to the 1, which is -1. That's your first term. Okay, for second term, I'm going to plug in n equals 2. -1 square is +1. n equals 3 will give you -1. n equals 4 will give you +1. And keep on going. That's the first 4 terms. Do you see this dot, 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 dot? That means it keeps on going, okay? There are infinitely many terms. Remember that. Okay, so clear what kind of function we are getting here? Only 2 values, -1 and +1. But that's it. That's the sequence, and it has a nice little formula. It's a function. Okay, so this example we did in the previous video, right? 1 over n. And as you already seen, the terms are 1, 1/2, 1/3, 1/4, and so on. Okay. Now, we did talk about that these are functions. So what will the graph of such a function look like? If it's a function, we should be able to graph it, right? Okay, so let's see. Let's draw the -1 to the n. Let's draw the first one. Now remember, this is the thing, okay? We are going to draw these functions where the domain, which is the x-axis, right, is not all real numbers, but only these positive integers, 1, 2, 3, 4, 5, 6, and so on, right? These are the domain. This is the domain. Okay. Let's draw this sequence, this function, the first one. So at 1, the value is -1, right? Let's say this is -1, and let's say this is +1. So at 1, the value is here. At 2, it's here. Then 3, then 4, then 5, then 6. Do you see what it'll look like? That's the function. That's the first one. Understand? Let's draw the 1 over n also, just so that you get an idea. Okay, again, it's at 1, 2, 3, 4, 5, 6, so on. So let's say this is my 1 here. So at 1, the value is 1. Then we have a 1/2. Then it's a 1/3. Then a 1/4, then a 1/5, then a 1/6. This is 1 over n. This was -1 to the n. So, understand this very, very clearly. This is the sequence 1 over n. And if I ask you to graph the function f of x equals 1 over x, what will it look like? Very similar idea, but what will it look like is this is 1 over x. That's 1 over n. Do you see the difference? Here, the domain is all real numbers, so you fill the gap. Here, you will have discrete dots because the domain is not all real numbers, but only whole numbers. Okay, so sometimes the definitions of a sequence is not given just with one expression, okay? Sometimes the definition can look a little bit different. This is a particular type of sequence. These are called recursive definitions. So here is an example. So this is how I'm defining my sequence, okay? I'm saying A1 is 1, A2 is 1, and AN is AN minus 1 plus AN minus 2 for n greater than or equal to 3. So this whole thing is the definition of the sequence. Question is, do you know how to write the terms of the sequence? Let's see. So let us write down the first term. First term is A1, which is given to you, is 1. Second term is A2, which is also given to you, is 1. Now what is the third term? What is A3? That means you're going to plug in 3 here. This formula is for all n greater than or equal to 3. So if I ask you find A3, okay, you're going to plug in 3 here, which is equal to, you're going to plug in 3 here. So 3 minus 1, that's A2, plus 3 minus 2, that's A1. So to find A3, you have to use the previous 2 terms, add them up. So what will it be? 1 plus 1, 2. Guess what A4 will be then? Plug in 4, then plug in 4 here, which is A3, and 4 here is A2. Do you get the pattern now? So to find the next term, you have to add the previous 2 terms, A3 and A2. 2 plus 1, that's 3. Now you don't have to write all of this out, right? You understand how to find the rest. So what will be the next term? 3 plus 2, 5. What will be the next term? 5 plus 3, 8. That's what the sequence will look like. So if I give you just this number, it will be pretty hard to figure out the formula. Okay, if the formula is given, okay, you can use that. So recursive definition, you're finding a term using the previous terms. Now this is a very famous sequence. It's the Fibonacci sequence. Okay, this is how you find the terms of it. So different ways, but sometimes you'll be given a formula like this or a definition like this, and you can figure out the terms, and we will do some we'll find the limit of this sequence, we'll look at bounded sequence and monotonic sequence and so on and so forth. So that's coming in the next videos.